Hello and welcome to this short session on machine vision. Simple and Adaptable is the title, just how we can talk about machine vision in the current context of how it's now become more simple to get into machine vision, to use machine vision and deploy machine vision successfully for tasks that are needed within industry with regards to inspection using this technology. Brief agenda. We're just going to go through the basics as a refreshing technology standpoint for machine vision in general. We're then going to talk about how we can keep it simple before talking about how we can adapt to more advanced solutions without the additional complications, and then how SICK can help you in this area. My name is Sandhu. I'm responsible for the machine vision systems within SICK in the UK and Ireland. So yeah, I hope you enjoyed the session. Thank you. So, the basics. Vision was a technology that was developed to emulate human inspection and manual inspections back in the 50s, initially when it first became industrialized, and ideally you're looking to benefit in a few different ways, in terms of potentially reduction or redeployment in labour, improving your quality and yield aspects in production, and increasing the production rates, all being well. So reducing waste and making sure that the production is at the best levels possible. Now, typically the vision inspection I'd like to break down into four key steps. So first of all, we take an image of something. It's a camera at the end of the day that's taking a picture of something in some way that's going to be inspected. So that image then needs to be analysed. We then need to make a decision, send a result out, and then take action, and then wait for the next one. So quite a simple process when you break it down. Practically, in that loop, taking a picture of something, the example there is a part. It's a brake pad. Analyze is one of the options. So with the intelligence within the vision system, in this case, measures the width. If that width does not fall beyond within the limits specified, then they make a decision in terms of it's not passing the criteria, and then the action can be taken, be it a reject or stop the line or divert, and then we wait for the next one. So quite a simple strategy. Now, in terms of the types of inspections that machine vision gets involved with, the majority of them fall into one of four categories highlighted by the letters at the bottom of the screen. And I'll just go through these one by one. We talk about positioning. So we're using vision to identify something where it is and report perhaps positions out something like a robot for picking it up. We talk about eye for inspection. So we're checking that something that's being manufactured or produced is at the right levels of quality in terms of its size, as we've just been talking about in the previous slide, or maybe it's all the features necessary to warrant it being at the right level of quality to pass out for shipping on to the next phase or the customer. Measurement, we can look at machine vision systems to measure objects or items that are being produced to make sure they're within the right limits of production. And of course, we could be reading something. We could be reading a barcode, we could be reading a 2D data matrix code, or we're checking some printed text. So usually precision inspection, measurement or reading is the areas where machine vision gets involved. Or a combination of these tasks. That's the other thing, compared to, say, standard photoelectric sensors to a degree. We talk about a combination of the tasks, so the system could be doing positioning and inspection and measurement, or even reading, all at the same time. And in terms of the industries that can be covered by this level of technology, as you can imagine, it's across the board, from packaging to automotive, food and beverage, etc., etc. What you see there. So machine vision gets involved in pretty much all aspects of industry. So let's keep it simple, as the name suggests. If we look at a vision sensor, for example, in this example, we can look at a typical application or typical problem where we're checking to see if there's a printed code on potentially an item of food, let's say. And so you can see there with a vision sensor, quite straightforward application to see if it's something there or isn't there. In the same way that we looked at the brake pad before in terms of measuring its width as an example. But then these are all potentially looking at areas with a standard 2D type system, which is more contrast based, whereas a 3D sensor, we're using a technology called laser triangulation as one method of imaging in 3D in 3 dimensions. Means you can start to inspect based on height data, the Z-axis data as we call it, as opposed to just the contrast with a standard camera, and that can start to give you more height-based inspections, as we can see here, looking at potential defects in a part like this, which potentially wouldn't be normally visible to a normal camera. And then once you have a combined situation where you could be using 2D or 3D, you can start to develop more complex solutions, but still with the simple hardware, the simple generic systems that can actually be talking to robots, in this case for picking and placing, or even to say another type of robot for quite highly advanced picking off a belt in this example, but still only using vision sensor technology that's very easy to configure and deploy. Okay, and just a little point at the bottom, when you have a task that's defined, and of course when looking at solving applications with machine vision, you always have to make sure that you've clearly defined what you're trying to do. The choice of what you need to use should be relatively straightforward, and people in the industry, including SICK, we're all here to help you get to the right solution and help prove that what's capable with the certain technology. So just a brief overview again of some of the types of inspections and tools that the vision sensor may have. For example, we talked about the P, the I and the M before in positioning, measurement and inspection. So typical inspection here, for example, tools used here to verify shape. You can see here in a molded plastic component here, making sure that it's been produced correctly. We talked about print inspection, making sure that the print is present, all the print is present here on the item of packaging. We can talk about the correctness of even the components being placed on a PCB in this example, making sure that we train the pattern of even a simple amount of text that could be used to verify correctness, as well as looking at labels and logos on labels in the same way with regards to packaging in all types of industry. In terms of the positioning aspect, we could look at the same component here that we looked at earlier, in terms of, but instead of as well as looking at verification of the shape for it being made correctly, we could be looking at positioning, we see here with some crosshairs, to make sure that it could be located and picked correctly. In the same respect, random orientated parts or objects, could be items of food here, that regardless of their shape could be identified, located, and then communicated out in terms of position for guidance solutions, as well as making sure that clearance in this third example is available for potentially a robot to come in and actually pick it up. And also we could use vision sensors in the simple way with positioning tools. For an example here, for line guidance, if you have an automated internal vehicle that's traveling using a line on the ground to move around and to follow its path, then the vision sensor could be trained to say, always find me the area of the line itself, and if there's any deviation, report that out. And then we come to measuring. So measuring tools could be measuring if, in this case, holes are stamped in the right positions and measured to the right tolerances to make sure that the assembly is correct, widths of components, as we talked about with measuring things before, as well as making sure that angles in terms of manufacturing of components and circular tools can be used to measure, to make sure that things are being produced at the right levels of quality. Now we talk about the examples similarly in three-dimensional areas, and looking at where the height data can help us in the same way in terms of inspection. Here we can see here making sure that maybe there's the right number of bottles, but with the height data we can actually check to see if those caps are all present and actually aligned straight, as well as in this confectionery example, making sure that all the items here are present and and stacked to the right level, to make sure that the height is all okay inside the box here. Positioning wise, and if we talk about a 3D vision sensor here, we can see that we can make sure orientation of this single pack, but also in this multiple pack example, to make sure, if for example here where we have one slightly at the wrong orientation, can be detected to make sure that the packing and shrink wrapping processes can be done well and doesn't cause any stoppages or downtime. And here with measurement tools, looking at 3D vision sensor, making sure that levels in containers here, looking at food or even in other consumer areas, making sure that fill level is actually at the right level, not too low, not too high, and potentially wouldn't affect any sort of wrapping and packaging, making sure that everything is within the boundaries of the container. So when we talk about a vision sensor, it really is about keeping it simple in terms of a very broad diagram here, in terms of when you have your vision sensor, which typically has inbuilt lenses and inbuilt lighting. So, you know, obviously with lighting being a critical area, making sure that you've got good levels of lighting and an inbuilt light will help. Making sure that you've got the power supply in, and then connection to usually a PC for configuration purposes only, and that would be either with some software that sits on that PC or maybe even just a web browser. Once configured, that connection wouldn't be needed as such, and all you would need is the vision sensor itself and some power, and if you're connecting any I/O to it, it would also come out of here, and you're talking about a very straightforward setup. And the GUI, the graphical user interface as we sometimes call it, it doesn't need to be complicated. Here an example of one shown is a simple component that's asked to be measured in terms of its width, and you can see that the actual graphical user interface, the GUI, is a very simple 3 tabs for looking at the image, a run and an edit, and we have various tools here that we can just simply drag and drop onto the screen and to give us the measurements or the inspection that we need to do. So we're working towards just an ideal setup here in terms of a typical vision installation, where, for example, we had a conveyor here, let's say, that's producing some components. We have a potential already inbuilt mechanism for diverting anything that's found to be not at the right levels of quality. We can start with our camera that's got inbuilt lighting and lens that could be connected to a simple trigger sensor to make sure it triggers the camera to take the picture at the right time. An encoder may be needed if that belt speed is not consistent, but that, again, very simple, straightforward connection directly into the vision sensor, and it's very easy to set up. Of course, the I/O that's coming out could be activating the divert or reject mechanism. If needed, extra information could be sent up to a PLC for more in-depth analysis, and we could be connected to a robot on a simple user screen for extra control, and the robot could receive the information over from the camera that's in a predefined interface that a lot of companies, vision companies and robot companies, have already done. So the hard work is done in talking from the camera to the robot, and then this can develop a very simple, straightforward robotic application. So let's talk about adapting to more advanced solutions. So we've talked about some basic inspections at the moment, but if we start to look nowadays, especially as manufacturing processes become more advanced and we're using more and more advanced technology, we talk about potential applications within industry that are needed, where we need to identify and locate multiple items in a potential conveying environment for picking and placing with a robot. We may need to look at a label in the logistics world to make sure that all the right information is on it, as well as, you know, labels in other packaging based industries such as consumer goods and even automotive, to make sure that it's the right logo, the right code, the right address, etc. As well as that, in the automated world now, where we have lots more automated vehicles running around factories and depots and logistics areas, if the identification of the correct position under a trolley or dolly here or a pallet could be done with a vision system, it makes things operate much more efficiently. As well as picking, if we talked about robots earlier, we talked about picking from a belt here, we could be talking about picking from a bowl feeding or feeding system to make sure we can singulate and identify individual components to be picked correctly, as well as checking information on even down to the PCB pin level inspections, in terms of making sure minute pins are correctly inserted, correctly placed, and also all at the right height. Again, we talked about robots there, from small objects here over to large potential objects for picking, for example, in the automotive world, and even now with colour inspection and quality inspection all at the same time for potential pick and place, but also to make sure, even in this example, baking degree is correct. Then these are all advanced machine vision tasks that are now required, but we don't really want to add complication to any kind of simple guide to setup, because I don't think we need to. And this is where a lot of vision companies are coming from, including SICK, that we can now provide the more complex solutions without having much more, if any, complication. Because it's not a black art. I know machine vision was considered a black art and perhaps still is in certain cases, but more advanced does not necessarily mean more complex, and this is what we're trying to say here. So let's take something as an example. Here's an everyday, something we use every day, all of us, and that's a smartphone. And okay, we all like them, we use them to do various tasks. So we all have a device, we all have different kinds of apps, so the apps will tailor the functionality of that smartphone to do different jobs, and everyone has the same hardware more or less, and depending on what apps they have, their phones do different things. So we've looked at this sort of concept and trying to adapt it to the machine vision world. So, for example, there's many different types of cameras: 2D cameras, 3D cameras, cameras that do various tasks in one way, cameras that do different kinds of tasks, to do robot guidance or to inspect a label or whatever. So, what about reducing this? So we all have a much easier choice in terms of what kind of camera we need, and let's tailor the software, or have more of an app style as we see with the phones, so we can pick and choose what we want our cameras to do and even possibly change them without too much hassle. So imagine a situation where you could have a developer working on what's called a sensor app or even a vision app, put it onto a device, and then when the customer says, I need something to do a particular task, in this case identifying different parts, maybe for robot guidance, they go, okay, I'll just have that particular device with the right app, and then I can go away and easily configure my system to work. And that's the idea behind this tailored software or app based concept. So rather than where we saw tailoring the functionality of the smartphone depending on different apps, here we can see if we had different kinds of apps for a vision system or machine vision camera, we can therefore almost follow the same concept to make things very easy to use. So at SICK, this is where we come in. We have taken that idea and we've created an environment what we call App Space, and we have our own developers. Also we have partner developers, all part of this what we call Developers Club, and we've created and continuing to create many different types of sensor app that can be easily deployed onto the end device. So the customer in this case doesn't need to know what's behind in terms of all the code that's gone on in the development. That's the job of the developers and SICK as a company in this case, and all the person using the device at the end of the day would need to see is the fact that I've got the right app. I can access it, let's say, via a web browser for a very easy to use configurable graphical user interface, as we've spoken about before, and that makes things a lot easier in terms of having generic hardware and then picking the right app to use on your particular task. And those solutions now can come in different flavors. There's a few mentioned here in terms of label checking, inspecting the connector pins and electrical connectors, looking at basic logos and inspections for shapes and objects, color sorting, belt picking, robot guidance, looking at the dollies and trolleys and pallets and positioning in high bay warehouses, racks. So there's just a few there in terms of what's been done from a SICK perspective with regards to particular tailored apps that we've used this concept to create easy to use vision solutions. So those tasks that I mentioned before all now have a particular app that go with them for belt picking, label inspection, picking from feeders or robot guidance, checking electrical connectors, large item or robot guidance for small and large based systems, looking at the logistics world and the pallets and the dollies, as well as color inspection. So we've done the hard work, and these are almost like oven ready to go solutions that you can deploy in a minimal amount of time. Because at SICK we are hoping to make machine vision more accessible to everybody within industry, because we don't believe it should be a hard task to deploy and use this type of technology to help everybody become a bit more efficient in terms of production processes and manufacturing. There are also some links here to some videos and to some information on our website that with the slides you'll be able to access these and find out more information, specific solutions that you may be interested in. And of course you'll be able to contact us and there'll be contact information available as well.
For belt picking applications, our newest innovation, the Tri-Spector P1000, provides a flexible, cost-efficient, and convenient solution. Tri-Spector P1000 is a compact, programmable 3D camera, which enables tailor-made solutions for more efficient production. To ensure smoothly running processes in the packaging industry, the detection of objects must take place continuously. With the new Tri-Spector P1000, objects are detected with the help of 3D vision. Using height-based product detection, the product's design can be in virtually any geometry and color, and the 3D camera still detects them, often without changing the camera's settings at all. With Tri-Spector P1000, the picking process can be adapted according to the product's actual shape, reducing the risk of collision and product damages. Also, detection by height enables detection of low-contrast targets, even when the belt and products have the same color. Sorting and checking objects by length, width, height, and volume is no problem for the Tri-Spector P1000 3D vision camera. Tri-Spector P1000 is the perfect solution for belt-picking applications in the packaging industry. Choose Tri-Spector P1000 to maximize your productivity and product quality.
Thank you very much for your time, and I hope you've enjoyed this short session. My name's Neil Sandhu again. If you need to get hold of me, the details will be available. Thank you very much. Goodbye.